Now, the first chapter, electric charges and fields. Nowadays, we know this thing, the importance of electricity in our day-to-day life, right? Now, the building block of electricity, that is electric charge, right? So, first of all, we have to understand what is electric charge, right? Now, let's try to understand what is electric charge and how it was discovered. So, during the experiment, as discussed here in the text, see the figure 1.1. If one glass rod is suspended with the help of silk thread, which one is rubbed with silk cloth? And if we take another glass rod, which one is also rubbed with silk cloth, and then after we place those two close to each other, then we can observe they repel each other. Okay. Now, so these two rods repel each other. Now, if we perform another experiment in which we take plastic rods in the same manner, one is suspended with a silk thread and rubbed with fur, and another one is also rubbed with fur, and these two plastic rods are placed close to each other, then we can observe this thing again, they repel each other. But if we take this plastic rod rubbed with fur close to the glass rod rubbed with silk, then we can observe they attract each other. Okay. And if this plastic rod rubbed with fur and glass rod rubbed with silk are touched to each other, then after, if separated and placed close to each other, there is no effect of any type of force. So, something is there. Which one is the cause of this particular force? Then, scientists carried out detailed studies related to this cause of force. And then they conclude this thing, the electric charge, which one is the fundamental intrinsic property of matter, just like mass, is the cause of this particular force. And this force is electric force. And when detailed studies related to the charges were carried out, then scientists came to know about this thing. The charges are of two types. Charges are of two types. And they have characteristics opposite to each other. Opposite to each other. But experiments shows this thing, these two types of charges have the tendency to nullify the effect of each other, and therefore scientist Benjamin Franklin suggested this thing. The charges are called positive charges and negative charges. Then conventionally it was accepted the charge possessed by proton, that is considered as positive charge, and charge possessed by electron, that is considered as negative charge. Clear? Magnitude wise, both these charges are same one, but one is positive, another one is negative. And this positive and negative, that is called polarity of the charge. That is called polarity of the charge. Each and every atom or molecule that is electrically neutral. It implies that the total amount of positive charge and total amount of negative charge residing in that particular atom or molecule, that is the same one, and therefore the resultant, the net charge, that comes to zero, so we can say are electrically neutral. Clear to all of you? So now here we can conclude like this. Electric charge, that is the fundamental intrinsic property of matter. Charges are of two types, are called positive charges and negative charges. Okay. Then we can say this thing, like charges means positive positive or negative negative charges repel each other. And unlike charges means one positively charged, another one negatively charged, attract each other. And this we can understand with the help of that experiment of rods. Clear to all of you? Now, there is a simple apparatus with the help of which one can detect the presence of charge. See, this one is that instrument, the device named as electroscope. Now in that, this one is the conducting rod, which one is placed in the evacuated glass jar, and at the end of it, these two are two thin gold foils. Okay. Now this one is also conducting sphere. Now suppose we have one glass rod rubbed with silk. Now when glass rod is rubbed with silk, then the charge deposited on the glass rod, that is positive charge. So if this glass rod is touched with this sphere, then positive charge attract negative charges. Now negative charges are possessed by electrons, and electrons are free in metal. So these electrons will be attracted towards this rod. So negatively charged particles, electrons will be accumulated at this particular end of the rod. Now, at the end of this rod here, two gold foils are there. These two will be positively charged because negatively charged electrons are removed from this one, they are transferred here. So when both are positively charged, they repel each other. So resultantly here we can observe this thing, the repulsive force exerts between these two foil, and the separation between the two foil will increase. So we can easily understand this thing. Yes, this particular object placed here, that is charged one. And here we can understand with the help of this instrument as whether this one is positively charged or negatively charged. Now initially suppose this one means the gold foils are positively charged. So repelled but will be in the steady state. Then after suppose positively charged glass rod is placed here, then more number of electrons when attracted by this one, and due to that when this becomes more positively charged, the separation increases. So we can say this thing, yes, this is positively charged. But if this rod placed here, suppose it is plastic rod, so it is negatively charged, then when electrons are transferred here and some positive charge on this gold foil is nullified by those electrons, then the net amount of charge on the gold foil decreases, and therefore the separation between these two decreases. So we can say yes, this particular object placed here, that is negatively charged. So electroscope, that is the device with the help of which one can detect the presence of charge as well as which type of charge is present on that particular object. That can be also understood with the help of this one. Clear to all of you? Then after the topic, that is conductors and insulators. So actually the matter or the substances available in the nature are categorized in three categories depending on their conductivity or capability to flow the charges, means to pass the current through it. Conductors, insulators and semiconductors. Here we have to discuss conductors and insulators. Conductors are such materials through which the electric current, it implies that the electric charges can easily flow, are called conductors. But those substances through which electric charges can't flow easily or are not able to flow it are called insulators. Okay, semiconductors have the conductivity somewhat moderate one. Later on we will discuss that particular part. And charges have the characteristic of transfer. Charges can be transferred from one substance to another substance, right? And earth is very good sink of charge. So if charge is transferred from earth to any substance or any substance to the earth, then in this process, when the charges are transferred from object to the earth, then we can say the object is earth, or we can say the earthing is given to that particular charge. But whenever there is the requirement of charge, then earth can transfer the charge also. Here, so earth is very good sink of electric charge. Clear to all of you? Then after the next topic, that is charging by induction. Means if any body is electrically neutral, or we can say uncharged, then we can charge it. Means we can deposit charge on that particular body. But there are two methods for the charging of the body. One that is called charging by contact, another one that is called charging by induction. So let's first discuss charging by contact. Suppose we have two objects, two metallic spheres here, okay, as shown in the figure. One that is with charge Q, another one that is with charge Q0, that is G. So in other words, we can say one sphere is charged one, another one is electrically neutral or uncharged. Now suppose the contact between these two is established, means these two spheres are touched. Now for simplicity, here we consider both the spheres are perfectly identical. So as soon as the contact between these two is established, then we can observe this thing. The charge will be distributed equally on both the spheres. So now on both the spheres, the charge will be Q by 2, Q by 2. And now if these two are separated again, then now on both one the charge is Q by 2, Q by 2. But think about this sphere, which one was initially uncharged, and now charge on it, that is Q by 2. So initially it was uncharged, now it is charged, but that particular sphere is charged by making contact of it with charged body. This phenomenon or process that is called charging by contact. Another method that is of charging by induction. See, suppose we take two spheres as shown in this figure. They are electrically neutral. Electrically neutral means net charge is zero. But charges are there in it. Positive charges are there, negative charges are there, but the net amount of charge is zero means the total amount of positive charge and total amount of negative charge in it, that is same. Now suppose a plastic rod rubbed with fur. So when plastic rod is rubbed with fur, then experimentally we can observe this thing, it becomes negatively charged. Is placed close to the sphere, one of the sphere. But here be careful, the contact between these two is not established. It is just placed close to each. Contact is not established. Okay. So as soon as this negatively charged plastic rod is placed close to this sphere, then it will attract the positive charges and it will repel negative charges. So negative charges will be accumulated at this opposite surface of the second sphere, and positive charges will be accumulated at the surface facing to this negatively charged plastic rod. Now, keeping this particular rod as it is, if these two spheres are separated. So, if these two spheres are separated, means now this left side sphere is positively charged, we can say this right side is negatively charged. And now if this negatively charged plastic rod is removed, then redistribution of charge take place, and now this particular left hand side sphere will be uniformly positively charged and right hand side will be uniformly negatively charged here. So when plastic rod is removed, then redistribution of charges will take place, and resultantly this one becomes positively charged and this one becomes negatively charged. Now see, initially both the spheres were electrically neutral. Now both are electrically charged. But here the sphere is charged without making contact of it with charged body. અહીંયા આપણે contact નથી કર્યો, just બેને નજીક જ રાખ્યા હતા. So this is called charging by induction. Clear to all of you? Now example 1.1. How can you charge a metal sphere positively without touching it? Simple thing. Suppose we have a metal sphere, which one is electrically neutral. So now place negatively charged plastic rod close to it. So negatively charged electrons means negative charge will be accumulated at this opposite surface, and positive charge will be accumulated at the surface close to this negatively charged plastic rod. Then after keeping this plastic rod and this sphere as it is, connect this negatively charged surface of sphere with conducting wire to the earth. So in short, we can say give earthing to this negatively charged surface of the sphere. So here the excess electrons will be transferred to earth. Okay. Now, when excess electrons are transferred to the earth, then after remove this earthing, keeping plastic rod and this sphere as it is, just remove this earthing. So now, on this particular sphere, there is excess positive charge. Now remove the plastic rod. So redistribution of charges will take place, and these charges will be uniformly distributed, and finally the sphere will be positively charged. In the same manner, by taking here glass rod rubbed with a silk cloth, so that is positively charged, we can charge this sphere with negative charges. Clear? So this one is Illustration number 1.1. Clear to all of you? Then after the next topic, that is basic properties of electric charges. Okay. Now see, when the distance between charged bodies or charged particles that is large compared to the dimension or the size of charged body or charged particle, then the charge will be considered as point charge. Will be considered as point charge. Now, first thing, that is additivity of charges. Additivity of charges means if large number of charges are residing on any object, any particle, or in any system, then to calculate the net amount of charge residing in that particular body, we have to take the algebraic summation of all the charges. It implies that suppose Q1, Q2, Q3 up to Qn charges are residing on the body. Then the net charge, that is Q1 plus Q2 plus Q3 up to Qn. So we can write sigma Qi, where I, that is 1 to n. But here we have to take algebraic summation. It implies that the positive charges will be taken with positive sign and negative charges will be taken with negative sign. So suppose, as per example, we take charge Q1, that is 1 coulomb. Coulomb, that is the unit of the charge. Okay. Q2, that is minus 2 coulomb. Q3, that is 3 coulomb. And Q4, that is 4 coulomb. So the net amount of charge, that is 1 minus 2 plus 3 plus 4, this much coulomb. Coulomb, that is the unit of charge, that is on behalf of the name of scientist Coulomb. Okay. Then after, second characteristic, that is the charge is conserved. Now, irrespective of any process takes place in electrically isolated system. Now, electrically isolated system means what? Electrically isolated system means anything which one is electrically charged can't enter the system, can't leave the system during the process. Okay. So, irrespective of any process takes place in electrically isolated system, the net amount of charge that remains constant. It implies that when we can think about one simple example. Suppose we have one electrically isolated system, and in that some constituent particles are there, and if the gamma rays are passed through it, gamma rays are highly energetic electromagnetic waves. So will interact with the particle and will ionize them. So here the pair production is observed. It implies that during this interaction, suppose 5 positive charges are produced, then 5 negative will be also produced. And again, if we take the algebraic summation, then the net produced, that will be equal to 0. So total amount of charge, that will remain constant one. Okay. So that is the conservation of charge. And in other words, we can say the charge neither be created nor be destroyed. Okay. Then after, quantization of electric charge. Quantization of electric charge means the charge available in the nature. It implies that when any object, any body is charged one or it possesses the charge, then charge will be equal to the integer multiple of some fundamental charge. It implies that we can write the charge available in the nature or charge residing in any system or on any substance, any object, Q that is equal to N where N that is integer. And E that is the fundamental charge and that is the magnitude of the charge on electron. And its value calculated that is 1.6 into 10 raised to minus 19 coulomb. So charge available in the nature that is always in the integer multiple of this one, means 1 into this, 2 into this, 3 into this, 4 into this. But you will never get such a charge where the charge is 2.5 into 1.6 into 10 raised to minus 19, not like that. Clear? So this is called quantization of electric charge. Suppose in any object, n1 number of protons are there and n2 number of electrons are there. Then the net amount of charge that is n1 into E, that is the total positive charge, magnitude of charge on electron and proton, that is same one. Just we take the charge on proton is positive, charge on electron is negative. So total amount of positive charge will be N1E and total amount of negative charge that will be minus N2E. So if we take the algebraic summation, then the net charge will be N1E minus N2E. Take E common. So we will get N1 minus N2 into E. But this again N1 minus N2 will be integer. Because after all, N1 that is number of protons, this is number of electrons. Clear? So this difference that will be the integer. Okay. Now here see, charge of electron or proton that is 1.6 into 10 raised to minus 19 coulomb. Then in 1 coulomb amount of charge, how many electrons are there? Or we can say how one can understand the amount 1 coulomb charge. So see, 1.6 into 10 raised to minus 19 coulomb, that is the charge of 1 electron. Therefore, in 1 coulomb, how many electrons are there? Take unitary method like this. Then we can calculate, that is 1 upon 1.6 into 10 raised to minus 19. Resultantly, you will get 6.25 into 10 raised to 18. It implies that if 6.25 into 10 raised to 18 electrons are together, or we can say if a system of 6.25 and 10 into 10 raised to 18 electrons is made, then we can say the charge possessed by that particular system, that is 1 coulomb. That is 1 coulomb. So 1 coulomb is large unit. Clear to all of you? Any doubt in this one? Now example 1.2. If 10 raised to 9 electrons move out of a body to another body every second, how much time is required to get a total charge of 1 coulomb on the other body? Now see, now number of electrons move out of the body in 1 second, that is 10 raised to 9. That is given to you. So amount of charge move out of the body in 1 second, that is 10 raised to 9 total number of electrons, and per electron that is 1.6 into 10 raised to minus 19. It implies that per second the amount of charge move out of the body, that is 1.6 into 10 raised to minus 10 coulomb. So again we can use the unitary method like this. If 1.6 into 10 raised to minus 10 coulomb charge moves out of the body in 1 second, then 1 coulomb of charge will move out in how much? So now time taken, that is 1 upon 1.6 into 10 raised to minus 10. So you will get 6.25 into 10 raised to 9 second. Now suppose we convert these seconds in here, then 365 into 24 into 3600 second, that is 1 year. Then this much second, that is how much year. So T, that is 6.25 into 10 raised to 9 upon 365 into 24 into 3600, this much year, means 1 coulomb charge move out after this much year from the body. Clear? Then after example 1.3, how much positive and negative charge is there in a cup of water? But here it should be mentioned, for a cup of water, we have to consider how much mass of that water. But in solution, it is considered 250 grams, so we take it. Now, mass of a cup of water, that is 250 grams, say it is small m. Now, molecular mass of the water, M0, that is 18 gram. So, if we take the substance equal to its molecular mass in gram, then that is 1 mole substance. Then that is 1 mole substance. And in 1 mole substance, the number of molecules or atoms, that is equal to Avogadro number, and that is 6.02 into 10 raised to 23. So let's first calculate the total number of molecules in a cup of water. So in 18 gram, number of molecules, that is 6.02 into 10 raised to 23. Therefore, in 250 gram, how many molecules are there? So we can calculate the number of molecules, that is 250 into 6.02 into 10 raised to 23 by 18. So we will get the number of molecules in a cup of water. Now, amount of positive and negative charge in a cup of water. So per molecule, how much charge is there? So H2O. Okay. So for hydrogen, 2 positive, 2 negative charges are there, H2. And for oxygen, 8 positive and 8 negative charges are there. Means per molecule, 10 positive, 10 negative charges are there. And each positive or negative charge possesses the charge equal to 1.6 into 10 raised to minus 19. So per molecule, 10 into 1.6 into 10 raised to minus 19 coulomb charge is there. So multiply it by total number of molecules and then solve it. You will get the total amount of positive and negative charge in a cup of water. Clear to all of you?